Hello, so welcome to this session about big data. This is a 400 session, so I assume that most of you know our services quite well, and I won't bother with giving you the basics of them. My name is Guy Ernest. I'm a solution architect. And what is a solution architect? And how does it relate to the orchestra that I'm trying to convey here? So I see a solution architect, or a CTO for this matter, as a conductor. We are not the best developers in the organization. We are not the best data scientists. We are just here to help and build an environment for the other people in our organization to thrive, to build application, and what we need to do is just to architect it in a good way, so it's actually going to be in harmony and work together, that each one of our organization can contribute to the system. So what we're going to do today is we're going to try to build a GIS system. A GIS system, the Geographic Information System, is basically quite complex. And it's starting with my personal story, is that I live in a small country called Luxembourg. It's a very small country, very clean, very quiet. Think of it like Switzerland, just without the Alps. And basically, I woke up one morning and I saw this picture from my window. And it doesn't work well in Luxembourg. We don't have these kind of things. So what I immediately did, as a very good citizen and a fairly good Android developer, I created an application that will allow me to take a snapshot of something which is wrong in my city. And using the GPS information of my device, I can upload this event into to the system and let the municipality know that there is something to be clean, and they can come and fix and keep the country clean back. So I took this application to the IT department of my municipality, and I discovered that it's not going to be that simple. They basically explained me that they have tons of GIS application waiting for implementation. They want to be able to give the availability of parking all around the city. They want to be able to read remotely the water meters in the city, so to save on the time of the operator going around the city. They want to see in real time where are the buses. They want to be able to do better or smarter traffic lights. And now and then, they're even hosting a marathon, and the complexity of managing hundreds of thousands of location and time during this marathon for a single day is something very, very complex. So building a GIS system in a wide municipality is not an easy task. And my system, yes, it's nice, it's clever, we can use it, but put it in line, and let's see when in 3 or 4 years we'll add it to the system. And I didn't like this kind of an answer, of course. So what I did is I tried to check how this kind of system are built usually in an organization. And what I see is that most of them are built on top of a database. And here I need your help to imagine the image I have on this slide, because I actually have an image, a poster for one of the DB vendor, but of course I cannot show the real picture from obvious reason. So I will give you the pop-up, and you can imagine what you have in each one of those sections. So in this database, I can have my queuing. So I have a table when I post the events that are coming in. I can store my images. I can have, of course, an event table that I see the status of each one of the table of the events as they occur, whenever they are started, when opened, resolved, closed, and so on. I can also do searches on geographic base, that is, give me all the events in a specific environment. I can do textual search using like, and I can, of course, run analytic reports and see how many events do I have, trends, and things like that. So this is basically putting too many things on one tool, and it leads immediately to the notion of this famous statement that when you have a hammer, everything looks like a nail. And it makes a lot of sense because you already have a database, you already have DBAs, you already have developers that know how to write SQL or ORM. So everything is a nail. So what I will argue is that, yes, you can do everything with database, but it's not the best option. Because not all those problems are actually nails. That is, whenever you are running some kind of analytic report on your database, your events or the transaction are suffering. When you are ingesting data very, very quickly, you need to have different hardwares than the one that you need to run other types of searches. And also the searches that you have, for example, with like that I showed, or the geographical ones, are not running very, very fast in a good performance way. So what I want to do is try to build something more elaborate, something that will use the right tool for the right task. So this is, let's build a system. I will start with my application. So this is the mobile application that I developed. It's getting from Cognito the permission to send data into the system, for example, to upload the images directly to S3 or to send the events to SQS. We are not going to spend a lot of time on this part of the application because, again, we want to build the backend. We want to build a big data system. And if you are interested in building such system, here are 2 sessions starting tomorrow that you can attend and learn how to do this kind of application on Android and iOS. So I started with SQS, but why not use Kinesis for that? So I will argue that you can use SQS in the beginning and Kinesis later on. From the ingestion side, it looks very, very similar. So all the developers or producers of the events, all you need to do is just change the endpoint they are writing, and instead of doing SQS send message, they just need to do Kinesis put record. So this kind of a change between SQS and Kinesis is something that is going to be very easy for us to do and build a system. And I want to build a system in 45 minutes, so I don't have that much time, and I want to do it very, very quickly. And this is why I started with SQS. But let's try to understand when, later on, I will switch to Kinesis. So why starting with SQS? Maybe I can start with Kinesis as well. But the differences with SQS and Kinesis is that Kinesis is basically a queuing system on steroids. So you can do things much, much faster in much larger scale. But the 2 main differences is that SQS has an auto-scaling capability. That is, you can send few messages, and SQS will be small for you, fewer server will serve you, and you can scale up and send thousands and tens of thousands of messages per second, and SQS will scale up for you. Because in the beginning, when I'm developing the system, I'm going to send very, very few messages a day, and in SQS I'm paying per message, it will be more cost-effective and simpler to start with that. Later on, once I have thousands and tens of thousands, hundreds of thousands events per second, I will probably need to move to SQS because the capacity and the cost. So later on, when there is a loss, the volume of the messages is very, very high. The cost for Kinesis, when you are providing the shards, take the effect, and then this is the right time to move on and change the system. The second difference is the at least once delivery of SQS. So in the beginning, I can read each message only once. I can have only a single worker that will basically come and process each one of the events. Again, in the beginning, it makes a lot of sense. I have very simple logic. I don't need to have multiple types of logic in my worker. So it's easy to start, and even the issue of duplication and out of order is not really important, or it's not noticeable at all in a very low volume. Later on, once I'm going to have a more complex logic, for example, I have different teams developing the logic of ingestion those events. Remember, I have some events coming from traffic lights, and I need to optimize the traffic lights timing, and some events are for this kind of a marathon, and I need to have different police arrangement around the track. So each one of the logic will be developed differently, and in this case, having multiple, at least exactly once, and in order delivery of the Kinesis is much more effective. So basically, those 2 differences will help you to decide when is the right time to move to Kinesis, or if you want, you can start with Kinesis if you have more time than those 45 minutes which I have. So this is my system. I developed the SQS part, the mobile application, and now I want to take the events and put them into DynamoDB as a NoSQL database. This is going to be my event table. Why do I want to have my event table in DynamoDB? Because it's very good for lookups. I can have a very high capacity of events, and I can scale up very nicely. So for my sake, it's going to be a very good place to put my events, and I'm going to show you an example how it's going to be stored there. And I also want to have Cloud Search as my textual indexer, because some of my data is coming in text form, comments, description of the events, and I would like to be able to search them as well. So I'm going to develop an Elastic Beanstalk application that will read each one of the events and push them into DynamoDB and to Cloud Search. So it might be very easy to start with Elastic Beanstalk. Again, I'm running in time, 45 minutes, how to do it faster. Elastic Beanstalk is very easy to deploy, and it has the ability to auto-scale. For example, if I need more readers because I have more messages in my queue, Elastic Beanstalk will have more workers reading those messages and scale down when I have fewer messages. So it's very easy to start with. And it has a very nice feature which is called the worker mode. So what does it mean in the worker mode? So this is my code. This is my Python Flask application. And the worker mode basically is registering that every time there is a message in the queue, it will be automatically pulled out of the queue and sent as post into my code. And then all I need to do is just parse the message, do my logic, for example, putting into a Cloud Search, putting it into DynamoDB, and then when I acknowledge that it's OK, I managed to update the event, I will just return OK, and Elastic Beanstalk will delete the message from the queue. So it's, again, very easy, very simple way of building a queue consumer. Let's see the code of the actual loading into Cloud Search. Again, you have all those slides, and even this kind of implementation is very quick and dirty. So it's quite easy to take the messages, take the events, put them into Cloud Search. This example, you see that I'm taking event by event and push them into Cloud Search. It is not a good way to do it. It's much better to do it in a batch mode. So you'll take hundreds or even thousands of events and then send an update of all those events in one batch call to Cloud Search. It's going to be very easy to do it later on when we'll switch, for example, to Kinesis, because in Kinesis, we're always buffering events when we are calling the service to give us those events. How do I going to write to DynamoDB? So in DynamoDB, I want to have different columns, and the one special column they're going to have is to allow me to have geohashing. So why do I need a geohash? Remember, one of the main features I want to have in my system is the ability to query data by geographical location. So it's important for me to have this kind of ability on all my system, especially in DynamoDB, because I want to get all the events in a specific region. But location is two values. They have the altitude and the longitude, and we need to convert them into a single key so I can search on. How do I do it? This is the geohash, and you can see the code that I'm using. I'm calling a service that will take the location information and convert it into a code. I used this library, the Geo library for Amazon DynamoDB, which is, again, quite simple. It's open source in GitHub. You can put it, and you can use Elastic Beanstalk to deploy a server that will do this kind of lookups and decoding and encoding of the data for you. This library is built on a simple implementation of crowd tree algorithm that basically takes the map, start creating smaller and smaller boxes, and then I can use those values of each of the boxes to locate all the events in this box. And basically, I need to use two functions. One is to encode, take the location and create one geohash, and decode, taking the geohash and create back the location. And then, when I have the geohash, I can do queries in DynamoDB. And this is the type of query you're going to have that give me all the events or all the records in the DynamoDB that are in this specific geobox and the geohash. So what is this geo box? Basically, I'm taking the geohash and I'm taking the first 5, 6, 7 digits of the code, and I use that as my in my table. So this is my table. I'm taking the key for each one of the events, the event ID. This is generated automatically by SQS or by Kinesis. Each one of the messages, each one of the records has an ID, and I use that. And then I'm adding my 2 columns, the geobox. And here I selected 6 digits. For me, it's OK because it's a good balance between the number of queries I need to do to DynamoDB to actually get all the events or specific map or zoom of the map that I want to show later on in my application. You can see that I also have a column of location, so I encode it in a geohash, but I also have the location, so I don't need to bother with decoding the geohash. I can just have the data in a JSON format. So it's supported by DynamoDB. So why did I build that? Now I can do queries on that, but because the geohash and the geobox is not the key of the system, I need to create a secondary index. So here is my secondary index, a global one, which takes the geobox and the geohash as my hash key and my range key, and now I can start running queries on that. How we're going to run these queries? So now we're going to build the operation view. So this is where my operators are sitting, and they want to see what events are still open, where they are, and so on. So again, remember, I'm the architect. I'm the conductor of this symphony. I'm not the best GUI developer, so all I do is some kind of a reference implementation of the application. So later on, my smarter, better GUI developer can take it and create something more nicely. So excuse my rough code, but again, I want to do it fast. I want to build just the infrastructure for the guys. And this is the view I want to see. So this is the map. On the bottom, you see my home. On the top, you see where I work and the image that I submitted. And let's see some code how to do it. And again, it's a very, very simple code. This is JavaScript. I took Leaflet, which is a very popular map plugin in JavaScript that I can use. And I have 2 functions. One, I'm creating the map, focusing it on the location of the operator. And of course, you can zoom right, left, and so on. And a call to DynamoDB to retrieve all the events that are in a specific region, which are shown, the get boundary, on this map region. Then I'm taking each one of the events and show them on the map by creating a marker for each one of them and filling up the information like the place, the image in this case, comments, or whatever I need to show on the map. So this is a very simple way of getting the data and showing that on the map directly. But remember that I also included cloud search, because I want also to be able to search data by text. And remember, the right tool for the right task. And if I need to do textual search, I shouldn't use something other than a text indexer, and in this case, cloud search is my favorite tool. But again, later on, I will talk about alternatives like Elasticsearch or other tools you might feel more comfortable with. So this is an example how you can run a query. This is the AWS console for cloud search. I can run a test query on the table. And I get, in the middle, I get all the results based on my queries. Again, I could use stemming, term boosting, all the goodies that you are familiar with in textual indexing. And on the right side, I get facets. So those facets allows me 2 things. One, to understand my data better, because it's doing this summarization of the data on the fly all the time. So I can see how many days I have in each event, how many events I have in each day, and what are the sources of my events, and so on. So this kind of information is very, very important for me as someone who wants to understand or discover what's going on in the data, and can also be used to filter down the events if I want to see only the events from today, and so on. So those facets are very, very important for me to do a very powerful GUI for my operator. Of course, I'm not going to use the console for that. I'm going to call Cloud Search directly from the browser. So this is an example how you just do an HTTP call to Cloud Search, giving all the information regarding what is the query you want to do, what kind of function you want to operate on that, and you get a JSON, take the JSON, and draw it on the map in a nice way. Another important thing that we want to know about Cloud Search is that the indexing options, because we have quite a few of them. The important ones are in which language we're operating. So my system is supposed to be running in Luxembourg. In Luxembourg, we're speaking French, German, English, Luxembourgish, you name it. We have every possible language. This is why I selected to have multi-language support on my comments. But if you are operating in a single language region, you can choose your English, Hebrew, Arabic, or whatever, Chinese, Japanese, whatever makes more sense for you. The second important part is the facets. You saw what I can do with that. Remember discoverability of the data, as well as drill down and filtering the results. And more importantly, for our use case, because we want to do a geographical GIS system, is the native support for location. So basically, when I have location, I can store it as it is. I don't need to do geohashing or so on. I can just put the value in the system. And then I can use the native support for that. So I can basically do a region that is bounding box query. I can do distance. I can even use the distance as a ranking operator on my query. So I can get all the queries that have the word clean, for example, on my data, but rank them as by distance from the center of the map that I'm looking now. This is the example that you see here. So this basic support is something that gives me a lot of possibilities to create a very powerful operational view for my GIS system. Now, I want to add another layer. You might call it complexity, but I will call it functionality to the system, which is the analytical level. That is, I want to be able to run analytical queries on that, and of course, for that I will use the data warehouse service, Amazon Redshift, that I will put all the historical events into the database. Then I can run trends and every type of report you can think of, create dashboard, connect all the BI tools, all the analytical tools that you are used to or want to use on your system. So this is a must for this kind of application. But I also added EMR because I think that there are many opportunities to do something clever on our data with EMR, which is not supported by the other tools that I have here. For example, so one thing I can do joins. I can do join between my event table in DynamoDB and data that is stored in S3, some kind of logs that I'm gathering in time. If you think about the metering that I'm getting, remember the water meters that I'm accumulating, or in the marathon the people who are running, and I get all the readings from their chips that they have. This kind of information is something that I can join together between the different sources. It's very powerful, and when I have other analysts that want to run this kind of queries, I can give them a good tool to do that. I can also copy the data. Remember, I want to take all the events from DynamoDB, the event table, into Redshift, so I can do the trend and the historical view of that. And I can also maybe run Spark, and Spark is something very popular. I have many customers who are asking for me or thinking about, I want to use Spark. I heard about it. I know it's very powerful. How do I do it on our system? And I will give you some example of that. So this is the basic example, how you do the Hive definition. So it's basic Hive. Whoever knows Hive and Hadoop will feel comfortable here. All you need to do is just create the table, define it, and then point it to where the data resides. It can be in a DynamoDB, like in this example. It can be in S3, or it can be on HDFS. So it's basically regular Hive, just you have more sources for your data. And this is the Spark example. Again, this is very popular. There are many options you can do that. It's quite new, so not everybody knows how to do it, on how to install it, but this is all you need to do. So this is one line calling the AWS CLI for EMR call, creating the cluster, and using the bootstrap action to pull out the script that will install Spark on your machine. It will take a few minutes for the cluster to come up, and then you can do the SSH and start with your Spark shell or run your Spark application. So it's very easy to start running Spark on your data with our application. What can I run with Spark? Again, if somebody didn't see those options. So this is one example. So Spark can provide you what we call Spark SQL. So here in this example, I'm basically, this is a Scala syntax. Spark is in Scala. So I'm creating a class, this is the event that I want to do. Then I'm fetching the data. I'm taking it, in this case, I'm taking it for S3. Then I'm running my query. This is the SQL that I want to run on the data that I got. And then I output it somewhere. So in this example, just print it out. But this will give you a very powerful, almost unlimited ability to take unstructured data, parse it, and query it, and it will run much, much faster than if you are used to the time of Hive, for example. You can also run two other flavors which are very popular. One is the Spark streaming that allows you to ingest the data directly from Kinesis, for example. So you have your events coming in. Again, the example that I mentioned in the beginning of the traffic lights information. I can, in real time, get this information, analyze it in memory using Spark streaming, and output whatever I want to do. For example, different timing for the traffic based on the actual traffic data that I get in real time to the system. And the second one is the machine learning, the MLlib. Again, unlimited abilities. The reason why I have it here, because I don't know what my analyst, what my developer will want to do. And now when I put EMR as part of the equation, I give them unlimited capabilities. OK, so we built a very elaborate system. It has a lot of functionality, but probably there are some problems. So let's try to understand what kind of problems we might have and why I think that those problems are not that critical. Security. Security is very important. It might have sensitive data in your system, and we still want to be able to run in a secure way. So there are many, many security measures in the cloud. I will highlight 4 which are relevant here. So first, nobody can write into your stream if they don't have credentials. So even if you have an API call to Kinesis, to SQS, nobody can write into this queue if they don't have the right credentials. And if you have sensor, you can get those temporary tokens from STS. This is a secure token service. And every time that you want to rotate them, you verify that the sensor is still valid. Or you could use Cognito for part of your mobile application to get those credentials. So remember, there is no way to write without those credentials, and you are controlling those credentials. Second, you should encrypt. We talked yesterday a lot about encryption, about how easy it is to encrypt data on S3 with server-side encryption or using your private keys. And now when you have a service for managing those keys, it's even easier. Also, all the data in Redshift is very easily to encrypt it. And I really encourage you to do it as much as you can. There is a very, very small penalty of performance, especially relatively to not having the system, because some regulator might say, no, you cannot have the data without encryption. Another important tool is CloudTrail, which is basically every time there's a change to the system, you can see this change happened. And I also encourage you to use MFA as much as you can. MFA now is supported with workspaces, which is a very nice way for you to build the system inside your VPC and provide MFA access, the multi-factor authentication access for your users, and so on. So it's very important for you to remember and put the right measures for security, because they are there for your service. I mentioned CloudTrail, so I just want to point you to a nice implementation that one of my colleagues in the Paris office developed lately, which is basically taking all the events from CloudTrail, which basically there are files in S3, and put them into Cloud Search. And then you can run queries on that and see For example, you can use the facet in this example of getting what kind of event, where the source of the event, or which IP are generating those calls. So you get a very powerful understanding about the security and who is accessing and who is doing what on your system. Okay, what about complexity? So it's quite complex, all those services. It's much easier to operate a single database with a single DBA and a single time that I install it. So these are the 6 lines of code that you need to do to start all the services that you just saw. So there is a call to create a Kinesis stream. There is a call to start a cluster of Redshift. So it will take very few lines of code, and in few minutes, your system will be up and running. And I believe that this kind of a setup is quite simple to operate. And again, I remind you that I'm here, I'm not the DevOps, I'm the architect. I'm trying to build the system quickly. Later on, my DevOps team will take it and then make it better. Especially if we're talking about the operations side, most of it is very easy because those services are managed service. You don't need to do a lot, or sometimes even nothing, to make sure that the system is up and running all the time. DynamoDB, Redshift, all those services are managed services that we are fixing if there's a problem there. And if I want to scale up, you remember the marathon that is coming, and I need to have many more shards of Kinesis to ingest the events for one day. This is quite easy, again, 6 lines of code to scale up or down each one of the services. But again, this is the architecture view, quick and dirty. This is not the way you're going to operate it. Your DevOps team will pick it up later and make a lot of automation and make it much, much more easy for you to operate once the system will be in production, in full scale, and so on. And for example, what they can do, instead of doing this kind of manual calls to DynamoDB to scale up, they can use the dynamic DynamoDB, which is a third-party library, which we endorsed lately, that listening to events on your DynamoDB tables and know how to scale up and down based on the load. So it's a very, again, automatic way, simple way to operate and scale up and down based on load. What about developers? So this is again, simple example. I will show a different one later on, but to let you understand that we need to learn how to call those services, and calling them is something that we, as architects, is something that we need to educate our users how to do. But again, it's not very complex. It's not a rocket science, as we call it. So again, this is an example of something that I think many of the developers don't know, and we as architects, when we are building this system, we need to teach them, is that there is something called a conditional update in DynamoDB. So in this example, remember that I submitted some kind of a report. There is some kind of garbage scattered around my house, and I want somebody to clean it. And then the cleaner comes to the place, and he cleaned the place. So I want to report, I cleaned it. But I want to make sure that he actually cleaned it because I want to see that he's in the right place. So he's in the right geobox of the actual original event. So in this case, I'm allowing the cleaner to update the event as closed only if he's in the right geo hash. So again, me as an architect is to take this example, show the developers what they can do. What they're actually going to do is up to them. And they are not going to use my examples, my code, because I use the CLI, which is probably not the best way for developers to work. They can use one of the many SDKs that we have, so they don't need to learn any new programming language. They can use their own favorite Node.js, Java, or whatever is comfortable with them, and they can work with those services, do the queries to DynamoDB, and so on. Okay, so it's secure. It's not that complex. It's probably very expensive. So well, we're in Las Vegas, so who thinks that this system costs more than $50 a day? More than $100 a day? Okay, so who thinks it's around $12.5 a day? So again, lucky guess. So this complex system with all the storage and NoSQL database and the textual indexer and the queuing system and the data warehouse and the Hadoop cluster, all those services together will cost you, again, more or less. I just went to the monthly calculator, the online tool, and I tried to calculate how much it's going to cost me. So there is a very generous free tier for DynamoDB, for Redshift. This is why you have only $157 a month and not almost $400 that you will have once you start paying for Redshift. But overall, it's around $12 a day for this very simple, basic application. So again, many, many services, but very easy to pick up, very easy to start in a secure way and in a cost-effective way. So I mentioned before many of the services of Amazon. I talked about Amazon DynamoDB, about Amazon Cloud Search, Redshift, EMR, but let's say that you want to have different services you feel more comfortable with. And in Amazon, it's very, very important for us that you have the selection. We don't want you to feel that you have to use our services. We want to, what we call, win your business every hour. And if you want to check other services, you can go, for example, to the marketplace. And this is the big data section in the marketplace. We have almost 2,000 products altogether, and about 150 of them, 145, are in the big data area. And you can choose any one of them and add them to your system. And a very popular example that I often see is people who would like to use SAP HANA as the database. And again, go to the marketplace, check for SAP HANA, and in a couple of clicks, you can then have those services and add them into your VPC and to your application. Okay, so we accomplished quite a lot in about 40 minutes. So this is my application after it graduated. Now I'm using Kinesis. I have multiple workers reading from the Kinesis queue. One of them is updating DynamoDB. One of them is updating Redshift. One of them is Cloud Search. There is even one connection to Spark running on EMR. I've got the views for the operation system, the views for the analysts, so they can actually do queries and optimize my city in a very efficient way. And again, I did it quite quickly. I gave you a few options to use along the way, but the important thing is that you can see that you should not be shy of using multiple tools, try to integrate them together, get each one of them to do exactly the right task for the right tool for the right task. So hopefully I managed to give you some answers, but I hope that I generated more questions than the answer I managed to get. And for example, I gave you an example of running Shark in front of Kinesis. But if you want, for example, to run Storm, which is again another popular streaming service, you can go to our big data blog. There are tons of information there. This is one blog that Raul from the SA team wrote about connecting Kinesis and Storm, and I really encourage you to go there, learn more, ask more, build more fun stuff, and the outcome of that can be that we can actually go to a city, and this is my dream, that I can take this system, go to a city and run all those services, all those parking availability and traffic lights and marathons, all those kind of services on one infrastructure, and give my developers, my external developers, startups, to take those ideas and fulfill them while they are using this kind of infrastructure that supports the scalability, the support of the GIS capability, and so on. So again, thank you very much for your time. I really appreciate your feedback, and let's see what we can build. Thank you.